Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your determination of ammoniacal by titration method. Okay, so here what we are going to do, we are going to detect the ammoniacal. Okay, we have to detect this ammoniacal. We have to detect this, and the method that we are going to use is our titration method. Okay, so come to the next slide. That is your introduction slide. We all know that in water, nitrogen is present in different form. Okay, this is your water, glass of water. Now, in this glass of water, nitrogens are present. We all know that. Nitrogen are present, and this nitrogen are present in a different form. Like they are present in a nitrate form, they are present in a nitrite form, they are present in a ammonia and organic acid. Okay, so these are the different form or organic nitrogen, not organic acid. It is a organic nitrogen. Organic nitrogen. So these are the form in which the nitrogen are present in a water. All these form are biochemically interconvertible and are a component of nitrogen cycle. Okay, all these form, that is your nitrate, nitrite, ammonia and organic nitrogen, they are what? They are interconvertible. Interconvertible means that it can be converted from one form to the another form, and they are what? They are the component of the nitrogen cycle. They are what? They are the component of the nitrogen cycle. In water, the ammonia are present in a surface water. Okay, if we talk about the water, then this ammonia are present in the surface water, means that it is present on the surface of the water, not the bottom of the water. Its concentration is generally low in a groundwater because it is absorbed in soil particle. Okay, so the concentration of the ammonia are generally low in a groundwater because it is absorbed by a soil particle and clay and is not leach readily from soil. Okay, so this is about the introduction part. Now the next one is your principle. The sample is buffered and distilled and ammonia absorbed in a distillate. Okay, so what we have to do, we take a sample and the sample should be a buffered and then distilled, and then ammonia are absorbed during our distillation, and then it is titrated with a standard sulfuric acid. Okay, so here the chemical that is used for the titration, chemical that is used for the titration is sulfuric acid. Okay, so the following table value are used for selecting the sample volume for the distillation. Now we are going to discuss about the particular table in which there are different values which are based on a selecting sample volume for the distillation. So this is about the principle of today's experiment. Now come to the next slide. The first column is for a ammonia in sample milligram per liter, and then we take a volume of the sample. Okay, so if the volume of the ammonia in a sample is around 5 to 10 milligram per liter, then we take a sample around 250 ml. If the volume of the ammonia in a sample is around 10 to 20 milligram amount of ammonia, if the amount of ammonia in sample is around 10 to 20 milligram, then we take a sample volume around 100 ml. And if the amount of the ammonia in a sample is around 20 to 50 milligram per liter, then we take a 50 ml of sample. And if the amount of ammonia is around 50 to 100 milligram per liter, then we take a sample of the volume around 25 ml. So this is about the amount of the ammonia in milligram per liter, and according to them the sample volume that we take. Now the next one is your apparatus used for this experiment. Okay, so we required a distillation assembly. Now this distillation assembly are associated with a borosilicate glass flask of 800 to 2000 ml capacity. Okay, first of all we required a distillation assembly. For that we have a glass flask, and this glass flask are made up of borosilicate, and the volume of this glass flask is around 800 to 2000 ml. It is the capacity of this glass flask. Now this glass flask are attached to a vertically to the condenser, so that the outlet tip may be submerged below the surface of the receiving acid solution. Okay, so this glass flask are attached to a condenser. And how they are attached to the condenser? Vertically. And so that the outlet tip may be submerged. Outlet tip should be submerged into a surface of the receiving acid solution. Now the next one is your reagent required for this experiment. The first reagent that we required is a mixed indicator solution. Okay, for the preparation of the mixed indicator solution, we first of all we required a methyl red indicator. Okay, so we take a conical flask. In conical flask, first of all we add a 200 milligram of this methyl red indicator. Methyl red indicator. Now before adding the methyl red indicator into it, we already add a 100 ml of 95% of either ethyl alcohol or isopropyl alcohol, either ethyl alcohol or either isopropyl alcohol. Now we dissolve 100 milligram of methylene blue in 50 ml of 95% of ethyl alcohol or isopropyl alcohol. Okay, first of all we dissolve the 200 milligram of methyl red indicator into a 100 ml of 95% of ethyl or isopropyl alcohol. Now again we prepare a separate solution in which we dissolve 100 milligram of methylene blue in 50 ml of 95% of ethyl alcohol or isopropyl alcohol. Now we mix these two solution, and by mixing these two solution, indicator solution are prepared, and this solution are prepared monthly. The second reagent that we required for this experiment is a indicating boric acid solution. For this we required a hypoboric acid, okay, in ammonia free water, and we required a 10 ml of mixed indicator that we prepared earlier. Okay, so what we have to do, we take a conical flask. In this conical flask, first of all we add a 10 ml of mixed indicator. Now into it we are going to add a 20 milligram of hypoboric acid in ammonia free water. When these dissolve into a mixed indicator, then we dilute it with the 1 liter of water. Okay, now come to the next one. Next reagent that we required is a borate buffer. For this we required a 0.1 normal of sodium hydroxide solution, and the volume of this sodium hydroxide solution should be 88 ml. Again we take a conical flask and we add 88 ml of 0.1 normal of sodium hydroxide solution to a 500 ml of 0.025 molar of sodium tetraborate. Okay, so again, uh, how we calculate the amount of sodium tetraborate, and the we all know that the molarity of the sodium tetraborate is 0.25. Okay, and uh, volume is what, 500 ml. Okay, so we all know that the formula is equal to W is equal to molecular weight into molecular weight into molarity into volume required divided by 1000. When we put all the values into it, we get the weight of the sodium tetraborate. Then the next solution is your standard sulfuric titrate, 0.02 normal, 1 ml is equal to 280 microgram of nitrogen. Okay, so for the preparation of this, how we prepare this reagent, you have to see the video of our, that is your solution preparation. Okay, this video are already uploaded in our account. You can go and check it and understand how we prepare all these solution. Now, the next one is your procedure. The two major factors which influence the selection of the method for the determination of the ammonia are concentration and presence of interference. Okay, so two major factors which influence that which type of method we have to select for the determination of this ammonia. The first one is your concentration and the next one is your presence of interference. Where interference are present and greater precision is necessary, a, a preliminary distillation step is required. Now what we have to do, we take a 500 ml of water, and into 500 ml of water we are going to add a this is your conical flask, 500 ml of water. Again, into it we are going to add a 20 ml of borate buffer. Okay, borate buffer solution to a distillation flask. Now after that we adjust the pH. This is your borate distillation flask. Now we are going to adjust the pH, and the pH should be 9.5, and this pH should be adjusted with the help of 6 normal of sodium hydroxide solution. After that we are going to add a few glass bead and use this mixture to steam out the distillation apparatus until a distillate show no trace of the ammonia. Now what we have to do, we put this we put the glass bead into this mixture and we steam it, and we put it into a distillation apparatus and allow the distillation until the until there is no trace of ammonia will be shown. Now the next one is your next step will be, we use a 500 ml of dechlorinated sample or a portion which is diluted to a 500 ml with a water. Okay, so we take a 500 ml of water of dechlorinated sample and 500 ml of water, and we remove the residual of chlorine either by adding a dechlorinating agent, which is equivalent to a chlorine residual at the time of the collection. If it is necessary, then adjust the pH with the help of dilute acid or alkali, and then add 25 ml of borate and then adjust the pH around 9.5 with the help of this 6 sodium hydroxide solution by using a pH meter. To minimize the contamination, leave the distillation apparatus assembly after steaming out and until just before starting the sample distillation. Now disconnect the steaming out flask immediately and transfer the flask to a distillation apparatus. Distill at a rate of 6 to 10 ml per minute with the tip of the delivery tube which is below the surface of the acid receiving solution. Now collect the distillate in 500 ml of eranimal flask which contain a 50 ml of indicating boric acid solution, and collect at least 200 ml of distillate. Lower the collected distillate free of contact with the delivery tube and then continue the distillation procedure for a last minute or two to cleanse condenser and delivery tube and dilute it with the help of 500 ml with water. So this is about the procedure. Now last step is that we have to titrate it titrate the ammonia in a distillate against a standard sulfuric solution until the indicator turn a pale lavender color. So this is the what? This is the end point. Pale lavender color is what? It is the end point, and again we we also take a blank solution through all the step of the procedure and then apply the necessary correction to the result. Okay, this is about the procedure. Last one is your calculation. Here ammonical nitrogen milligram per liter can be calculated by a minus b multiplied by 280 divided by V, where A is equal to volume in ml of sulfuric acid for a sample and B is volume in ml of sulfuric acid for a blank, and V is a volume in ml of a sample taken for a test. So this is all about the determination of the ammonium nitrogen by using a titration method. I hope you will understand. But if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platform, that is your Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or if you have further query, you can ask your query to the helpline number that are already mentioned in your slide. That is 7080833450. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.